So converting trig products to trig sums. So something like this. If I've got something where cos is times cos, the way I remember these is to simply use a little bit of logic. Where did it come from? So if I'm left with cos, it must have come from the cosine formula. But I want to be left with cos. So think of what the formula says. It goes cos, sine. Cos part is always positive. So I must have added the two together, and then the sines would have cancelled because one's plus and one's minus. So that's where it comes from. That one came from cos alpha plus beta. But of course, we might end up with sine cos. Well, then logically, that came from sine alpha plus beta. Now, in this case, it doesn't matter because they both go sine cos. Just got to be careful which one's the A, which one's the B, but in the end of the day, it doesn't matter a lot. But so it'll be sine A minus B plus sine A plus B. To keep it consistent, I'll keep the A minus B first, and then we always know it's. And then the other thing we might have is sine. Well, again, it's got to come from the cosine function, but now I would do a subtraction. So the cos's cancel, but because of the different signs, we'll go plus minus. Oh, right, that sine will be there twice. Also, why I put the A minus B first, because it would be cos A minus B that would have the positive sine. So keep it consistent with the A minus B first. Let's use it. Express as a sum or difference of trig functions. So if I want to get 2 cos 5x sine x, now I deliberately put the cos first here to point something out. In my head, the formula is sine cos, because I always think sine cos. Easy enough to change. Okay, so that's 2 sine x cos 5x. So where did it come from? Must have come from the sine function. It will start with the difference. So sine x minus 5x. Again, the order is important because if I get it the wrong way around, I'll have 5x minus x, and that'll make a huge difference when we're talking about the sine function. Keep it in the same order. That again is why I always rewrite it as sine cos. So I make sure I know that's the order, x, 5x. I get sine minus 4x, but of course sine is an odd function, so I can make that a little bit neater, and I get minus sine 4x plus sine 6x. Cos. Okay, well, must have come from the cosine function. Oh, hang on. I would have been left with 2 cos, not 1 cos. Well, that's easy enough. What I've really got is a half of 2 cos. Cos 3 plus 5 theta. I just contradicted myself. I didn't put the minus first. Oh, well, it's plus, so it didn't matter. Got away with it. Let's work it out. So I've ended up with a half cos 8 theta plus cos minus 2 theta because cos is an even function, so that would be the same as just cos 2 theta. If we want to work out 2 sine 45 cos 15, well, sine 45 is easy enough. Cos 15, we'd have to work that one out. But if I change this product to a sum, so we've got sine cos, so it'll be sine 45 minus 15 plus sine 45 plus 15, which creates 2 exact ratios that we know. Sine 30 is a half, sine 60 is root 3 on 2, and there's our answer, 1 plus root 3 on 2. Prove this relationship. Sine squared 5 theta minus sine squared 3 theta is sine 8 theta sine 2 theta. I'm actually going to start with the right-hand side. I'm going to turn that product into a sum. Sine must have come from the cosine function. So I've got a half, because remember it should have been 2 lots of. So I've got a half of cos, subtract 8 theta minus 2 theta, minus cos, add 8 theta plus 2 theta, and that's 6 theta and 10 theta. Now I'll use the double angle results, because I notice 10 theta is double 5 theta, and 6 theta is double 3 theta. So cos 6 theta will become 1 minus 2 sine squared 3 theta. Cos 10 theta is 1 minus 2 sine squared 5 theta. We've got the negative of that. The 1's cancel, and we end up with sine squared 5 theta minus sine squared 3 theta. All right, let's go back the other way then. So rather than trying to read those formulas backwards, There's your sum to product formula. Looks hard to follow, and that's why I don't remember it that way. 2 sine half sum cos half diff. Before I explain why I do it that way, let's look at the next one. We have cos plus cos. 2 cos half sum cos half diff. So now notice, they both finish in cos half diff. Not a problem. It starts with the same ratio you're working with. So sine starts with sine, and the cos starts with the cos. So sine goes 2 sine half sum cos half diff. Cos goes 2 cos half sum cos half diff. Cos minus cos. Hang on a sec, there's a negative sign there. That's a bit different. There's your key, it's a bit different. So this one's different. Instead of going positive 2, I go negative 2, because that's different. Instead of ending with cos, I end with sine. That's different. And instead of starting with the same function, I start with the other function, because that's different. So we end up with minus 2 sine half sum sine half diff. You'll notice I don't have sine minus sine, because I don't need it. And we'll do an example which will show you why. And there's the sine minus sine on the bottom. Okay, we're going to prove that this is equal to root 3. So on the top I have cos plus cos. Well, cos plus cos start with the same. So I'll get 2 cos half sum cos half diff. Then you'll see what I did on the bottom. Because sine's an odd function, I can make it plus. And that's why I don't need a formula for minus. I just make it plus. So it's now sine 75 plus sine negative 15. And that one will go 2 sine half sum cos half diff. Let's have a look at what we got. On the top, 2 cos half 90, cos half 60 over 2 sine half 60 cos half 90. Well, the half 90s, they're going to cancel. The 2's, they're going to cancel. I'm left with cos 30 over sine 30, which is cot 30, which is the square root of 3. We've got this equation to solve. Sine x plus sine 3x equals 0. Especially because it equals 0, this is going to be so much easier if I turn this sum to a product. So we've got sine plus sine. 2 sine half sum cos half diff equals 0. But you see, now it's a product. And we know when we got things that multiply together equals 0, then either the first factor equals 0 or the second factor equals 0. So I know either sine 2x equals 0 or the cosine of x equals 0. And they're boundary values, so very easy to solve. So 2x could be, it's 2x, we're going around the circle twice, 0, 180, 360, 540, 720, divide everything by 2. There's those possibilities. Cosine x equals 0, this one I only go round once. I get 90 and 270. Oh, well, I already have those anyway, so I didn't produce any new solutions. But overall, there's my solutions to the Trig equation, turning into a much simpler question by converting that sum into a product. Okay, we'll do 17G.